guys. Welcome back. Here we are at Cal 1. This is some tough stuff. Today we're going to be dealing with infinite limits. Now, you may have already worked ahead and done these problems because I realized how slow I was being in getting these explanations out to you. So hopefully you've got a better understanding of this than I think you do. So maybe this will make it a little easier. 2-4 is infinite limits. When we approach a number and the value actually goes to infinity, this is, an infinite limit. But one thing I want to make sure that you understand, and this is kind of tricky, technically the limit does not exist because infinity is actually unlimited. So yes, it is going to infinity, but if you specifically ask, the limit actually does not exist because it's unlimited. So anyway, so this is an idea that you've already experienced at one point, and that was with what we call vertical asymptotes. Okay, so you look at some graphs probably and saw that, vertical asymptotes. So anyway, so this usually happens with rational functions, and so how do we know when a function approaches infinity or negative infinity? Just think about this. This happens most of the time with rational functions and with an issue with the denominator. And so what we're looking at is a fraction. Now, I want you to just think through this real quick. When you've got a fraction and this number, for whatever reason, this number on the bottom gets really, really small, what does the value of the fraction do? So as this number gets really, really small, the value of the fraction gets really, really large. It gets really big. Okay, so let's just look at this idea. Okay, so make sure my sound. Sorry about that. Hopefully the sound will be a little better. I had to adjust my microphone. Okay, so let's look at this. So when the fraction gets really, really small, so 1 over, let's do a couple of these. Let's say like 1/10 or 1 over 1,000 or 1 over 1,000,000. These are really, really small numbers. Okay, but because we're doing the reciprocal of these, 1 over 1/10, 1 over something is actually the reciprocal of it. So this is actually 10, and this is actually 1,000, and this is actually 1,000,000. So you can see how, as this denominator gets really, really small, or as it goes to 0, that the whole value of the fraction goes to infinity. And so that's what's happening here. Now, the question is, sometimes, is it positive infinity or negative infinity? Well, that just generally depends on what the values are when they're approaching this is 0. For example, these values, these are all positive values. And so I'm getting positive values. So this one is a positive infinity. Okay, but if I were plugging in negative values, I would get negative infinity. So if this was a negative 10, this was a negative 10, 1/10, excuse me, then this would be a negative 10. Okay, and so then I would be getting closer and closer to negative infinity. So in conclusion, so as x approaches 0 from the right of 1 over x, we get 1 over positive 0, which is a positive infinity. I don't like that color. Let's trade out. We get 1 over positive 0, which is positive infinity. And then over here, as x approaches 0 from the left, These are negative values, so we get 1 over negative 0, which of course is going to give me negative infinity. So thinking about this as the number on the bottom gets smaller and smaller and smaller, the actual fraction is getting bigger and bigger. All right, and that's how we get to infinity, because infinity is bigger and bigger. All right, let's look at some examples of this. Okay, so here we have limit of x goes to 3 of 2 minus 5x over x minus 3. Okay, and so we're going to do both the right and the left-hand limit here. Both the right and the left-hand limit. So the limit as x approaches 3 from the right. Okay, as x approaches 3 from the right. Now, one of the ways to do this is to break this down into 2 minus 5x times 1 over x minus 3. And this is one of our limit laws. And I haven't discussed the limit laws with you. We'll talk about those later, but they're very, very intuitive, which means the limit of a function is the limit of the function parts. And so you can break up a function into all its little parts and do the limits of each little part and then just put them back together. So this would be like this. So if I plug in the 3 in the first one, I'm going to get 2 minus 15, which is negative 13. And then this one, the fraction, here we are, we're looking at 1 over, okay, so now we're going to get a positive 0 or negative. We're going to get a 0 from the positive side. From the right, these numbers will be positive. So if I plug in a number from the right, say 4, so 4 minus 3 is 1. And so that would be a positive number that I put in, and I'm getting a positive. So this is positive. So this is going to be positive infinity. Well, negative times a positive is a negative. So my answer is actually negative infinity for the right. Let's do the left. So now the limit as x goes to 3 from the left, same idea here. That's not right. Got 2 minus 5x times 1 over x minus 3. Okay, so now this one's still negative 13. Right. But now 1 over x minus 3, now we're coming from the left of 3. So now I'm plugging in 2. And when I plug in 2, I get a negative 1. So this is coming to a negative 0. So this is negative 13 times a negative infinity, which is positive infinity. All right. So now, since the left and the right do not give me the same thing, check this out. The left gives me negative. The positive gives me, right, there you go. You know what I'm saying. All right. So the actual official answer for the total would be that this does not exist. Okay. Therefore, the limit as x goes to 3 does not exist because the left and the right aren't the same. All right, so let's look at the second example. Same basic setup. We're going to do both the right and the left, and hopefully we will get the same thing. Make a little border here for you. Okay, so now we'll do the limit as x goes to 5 of x minus 7 times 1 over x times x minus 5 squared. We'll do from the right. Okay, so when I plug in a 5, I'm going to get a negative 2. Now, on the fraction, okay, so it's going to 0. We know it's going to 0 because when I plug in 5, I'm getting 0. So it's going to 0, right? But from the right, am I getting positive numbers before I hit 0? So if I plug in a 6, am I going to get positive? Yes, I plug in a 6, I have 6 times 1 squared, which is, of course, a positive 6. So from the right, I'm getting a positive 0, right? And so this is going to give me negative 2 times a positive infinity, which is negative infinity, just like the one before. And now we're going to do from the left. So again, when I plug in, I get the negative 2 here. But now when I plug into my fraction and I plug in a number from the left, say 4, okay, so that'd be 1 over 4 times 4 minus 5 squared. That's 4 times negative 1 squared. Am I going to get a negative? Absolutely not, because there's a square there. That actually is always positive, okay? And so this is also going to be a positive number. It's positive 4. So I'm getting a 1 over positive 0 again. So again, I'm getting negative 2 times a positive infinity, which is going to be a negative infinity. So now this time, we don't have the do not exist. Okay, we have the limit as x goes to 5 is equal to negative infinity of this particular function. All right, I'm going to stop there, and we'll pick up another video. This is video 1. We'll do a video 2.